there. So in this video, I'm going to be teaching you how to find the general solution of the final case of a homogeneous linear coefficient second order differential equation. So, again, I'm going to start with the auxiliary equation. This term is going to be just lambda squared. I'm just going to read it off because I assume you know this now. 4 lambda plus 5 equals 0. Now one thing you may notice is that this does not factorise. Or at the very least it doesn't factorise. Well, yeah, it doesn't factorise. So I'm going to use the quadratic formula here. So this is going to go lambda equals -4 plus or minus root 4 squared minus 4 times 1 times 5 all over 2 times 1, which is just -4 plus or minus root 16 minus 20, which is -4 over 2. Now, as you can see, this is going to involve complex numbers because I've got root of a negative number here. That is equal to -4 plus or minus 2i over 2 equals -2 plus or minus I. Okay, so those are the solutions to the auxiliary equation. Now, what do these mean? Well, in this case, you have to plug into a formula that's slightly more complicated than before because you've got two almost terms in the solution. So, the solution is going to be, or the general solution is going to be y equals e to this number minus 2 x times constant cos this number, the coefficient of the I, x, well there's just one, it's not there, so x plus d sine of the same number 1, in our case x, where c and d are arbitrary constants. So that is the solution. So as you can see, it's a pretty simple process through all three cases. So that was part 3 or case C, finding a general solution of a homogeneous linear constant coefficient second order differential equation. Thank you.